All right. So what we are talking about today, like I said, are derivatives of log functions. And these derivatives are additional derivatives that you can add to your list to study for your derivative quiz that will be coming up. All right. So we have two additional. Again, these are ones that you need to commit to memory. We have our natural log rule, and we have an any-based log rule. And the first thing I'm going to talk about here is our any-based log rule. And this is actually based on the change of base formula. And I'm not going to go through the whole thing, but you do need to know these. They come up quite often, and people have a tendency to forget them because they're not really something that you think about on a daily. Okay? So here, if you have log base b of x, this is equal to 1 over whatever you're taking the log of times the natural log of your base. So remember, this base could be anything. It could be a 5, it could be a 7, it could be a 10, it could be e, but that's what we're going to talk about up here. Okay, so you do need to know this. And again, this derivative is based on the change of base formula. Our natural log rule is when we're taking the derivative of the natural log of the absolute value of x, it's 1 over x. And I'm actually going to show you that the answer comes out the same, which is why it's the absolute value of x. So if I asked you to take the derivative of the natural log of just 1x, the derivative based on this right here is 1 over what you are taking the derivative of, or excuse me, the log of, so it's 1 over x times the derivative of the inside. So what's the derivative of the inside? It's just 1. So we get 1 over x, which is the derivative here. Okay, that's a chain rule. If I took the derivative of the natural log of negative x, okay, this is 1 over negative x times, what's the derivative of negative x? It is negative 1, so you end up with 1 over x. So do you see why that absolute value is there? So if you had, I don't know, the natural log of negative 2x, taking the natural, or the derivative of the natural log of 2x is the same. Everybody good? Okay, so these are really important, these two. So I'm going to go through and apply these derivatives, okay? And some of them will incorporate the chain rule. So if you're struggling with the chain rule, it's important that we make sure we're good, because you might have a product rule, but it's going to have a chain rule in it. Or you might have a log, and it's going to have the chain rule in it. So we need to be really careful and understand what's going on. So this is actually a prime example right here. So if I'm taking the derivative, dy dx, and I'm using the natural log rule, this is, and I'm putting this in quotes, my x term. So the derivative of the natural log of the square root of x, the first part of it is 1 over the square root of x. But then I have to take the derivative of the square root of x. So I have to take the derivative of this part now. So what's the derivative of the square root of x? It was one worth memorizing. 1 over 2 square root of x. So this is essentially the chain rule right here, right? We took the derivative of the outside and then the derivative of the inside. Okay. Plus, now we need to take the derivative of this. So I could think of this as the natural log of x to the 1/2 power, right? So isn't the derivative of this whole thing 1 over 2 square root of the natural log of x? Yes? Okay, so this is 1 over 2 square root of the natural log of x, but then I have to take the derivative of the inside. So what's the derivative of the natural log of x? It's 1 over x. So again, another chain rule. Okay, if I asked you to evaluate this derivative at, let's say, 1, am I finished at this point? Well, if I was asking you to evaluate a specific x value, do I have to simplify? No, I could just plug in my x value. 1 is not a good choice. Can someone tell me why? Take a look at my derivative. I have undefined. Does everybody understand what I'm saying right here? I just randomly picked 1 because it was an easy number to plug in, but what's the natural log of 1? 0. So it was a bad number to pick, maybe 2. Okay, but if I did want to simplify this, what is the square root of x times the square root of x? X. Okay, so what we have is 1 over 2x plus, can I just put this together? 1 over 2x square root of the natural log of x. I would stop there. Some of you are actually trying to simplify. I think there was a problem on the test that had a bunch of radicals. Your algebra was breaking my heart. But remember what I said? Like if it's a complicated answer, do you have to simplify it? So why would you put yourself through that headache? You're making it harder on yourself. Stop. Really? Just stop. I mean, it makes, number one, grading easier, just saying. But it also makes your life a little bit easier because what you need to spend more time on, you can. Because you can walk away from that problem if you know you've done the product rule or the quotient rule correctly. Okay, with that said, does anyone have any questions on this? Okay. When you have a trig function taken to a power, what did I recommend you do? Anyone remember? Yeah, rewrite it so that we can see the layers. So we're going to rewrite this as the sine of the natural log of x, and this whole thing is squared. Can someone tell me what kind of M&M I'm dealing with here? Absolutely, I have 3 layers, right? Okay, so when I take the derivative, dy dx is equal to, what's the first part of my derivative? 2 sine of the natural log of x, and this is essentially to what power? The 1. So do I have to do any parentheses? Do I need it? No, I'm good. Times. So then I move on to the chocolate layer, which is what? The sine of the natural log of x. So what's the derivative of the sine?
Cosine.
Just cosine. So it's cosine of the natural log of x. And then I've got my peanut, which is the natural log of x, which the derivative is 1 over x. Okay. If it was crushingly difficult for you to get to this point, but you are confident that you are done, are you okay? Absolutely you are. But we could rewrite this as a fraction, right, if we had to. Or I could just bring these two together. I could write it as 2 over x times the sine of the natural log of x times the cosine of the natural log of x. But I mean, there's so many ways that you could write that derivative. Essentially, are we done? Sure, absolutely. Okay, so maybe not as bad as we thought it would be. Everybody doing okay? Yes, dear?
Would you be able to factor out the algebra?
No. No. Okay, did everybody hear her question? She said, could you factor out the natural log of x? And the answer to that is no, because you'd have to take the sine of it first. So it has to do with your order of operations. Yeah. But remember, too, if you're going to factor something out, make sure it would be better if you had something like a rational function, meaning a fraction, numerator and denominator. And really, when you're factoring something out, you're looking for something to cancel out. And because it's not going to cancel out, yeah, let's just avoid it. Okay. Everybody good? Okay. All right, so here we've got a log. So we're going to take the derivative, dy dx, and really, again, we will have to use the chain rule. Does everyone see why? This is essentially my x term that I've got in that the derivative definition at the top, but I'm going to have to take the derivative of it because it's a function that's got more than just x. Okay, so when I look at the rule, it's 1 over whatever I'm taking the derivative of times the natural log of the base. So let's deal with that first. We've got 1 over what we're taking the derivative of, so it's what, x squared plus 5x times the natural log of 2. Okay, that's just the rule. And then the chain rule that I have to deal with is the derivative of what's on the inside. So this is 2x plus 5. Questions? Okay, I could rewrite this as 2x plus 5 over x squared plus 5x times the natural log of 2. I have 2 questions, but before I get there, does anyone have any questions as to how I got this? Okay, question number 1. Can I cancel this 5 with this one?
No.
Why? Okay. Right, correct. They are terms and not factors. Okay, so one was because this is in a set of parentheses. I could distribute the natural log of 2 if I wanted, but I don't have to. Okay, so does everyone understand the difference? Like, there were, I think on the Unit 1 test, I did see some people canceling like that. You have to be really careful. Meaning, I saw this. If you had an x squared plus 1 over an x squared minus 7, people did this. Okay, these are terms. So it's like you're looking at it, you see it, you're thinking too quickly, you need to slow down a little bit, so I'm just verifying. Can I do anything else to this? No, I'm done. Okay, questions before I move to the next problem? Am I moving too slow? No, just right? Just right. Okay. Question that I have for you. Should I rewrite this with the 2 on the outside, the square?
You can.
I would suggest it only based on the fact that you are going to have to use a chain rule here. And that's just a suggestion. What's the base of this log? There's nothing there. Is it a 1? Oh, it's a 10. So if I rewrite this as log base 10 of the cosine of x squared, do I have to use a chain rule? I do. Okay, so the first part of this is going to be the derivative is 1 over, I'm going to put this cosine squared of x, bless you, in the bottom, times the natural log of 10. That's just based on the rule, right? Then I actually have to take the derivative of the cosine of x squared. Just this part right here, plain or peanut? Plain. Outer shell, chocolate, right? Okay, so what's the derivative of the first part? 2 cosine x times negative sine. Right. I'm just encouraging you to not rush through. Okay? So really what I have is negative 2 cosine x sine x over cosine squared of x natural log of 10. Okay. Without anything else, is this done? Yes or no? If I said write your derivative in simplest terms, is this done? Why not? I beg your pardon?
Double angle identity.
That's one that we could do. Yep, double angle, 2 sine, cosine, right? Okay, what's another thing that I could do? That's one that people don't see, which I totally didn't even see it. Yes?
Could you cancel the cosines?
Could we cancel the cosines?
Yeah.
Yes, you can. So you have one here, and you have one here. What's sine over cosine? Tangent. Yep. So you could write this as negative 2 sine x over cosine x natural log of 10. You could then simplify it to negative 2 tangent of x over the natural log of 10. Okay, so do you see there's so many answers that you could have here? If you stopped up here, is it wrong? No. Okay, it depends on what the question is asking. Okay. Does anyone have any questions? These are all the same thing. They just look different. Okay? Questions? Are you sure? Okay. You guys are going to do E, and we're going to go back to that in a minute, but I want to look at this one. Woo! Whoa. Yikes. All right. What do I do? If I want to find dy dx, whoa. We've got some implicit in here. All right, so we have this multi-layer something or another going on here. And what's going on here? Ooh, product rule, yeah, with implicit, right? Okay, so if you go back to the directions, it does say find dy dx. All right, so that's what we're going to do. That means we need to take the derivative of both sides. So the first part of this is going to be our log rule, which we've got 1 over this part, which is the sine of x squared y times what? The natural log of 2. Okay, that's the first part, right? Times. Then I need to deal with this inside. What's the derivative of the sine? It is cosine, so we've got cosine of x squared y. Okay, and then we're going to do our little box here. So because I don't have any room, I'll just use a piece of paper. We're going to label, which is what some of us need to work on. I include myself in that. What is my f term going to be? X squared. What is my g term going to be? It is y. Okay, does everyone see where I'm going with this? Okay, so f prime is 2x. G prime, be very careful, dy dx. Good. So now I've got f prime times g, so this is 2xy plus f g prime, x squared dy dx. Okay, so how do I deal with this? This is still the derivative of the left side. So remember, if you're doing chain rule, this is the outer times the first inner times, yes. Okay, so this is going to be times 2xy plus x squared dy dx. And what's that equal to? This little old 2. Okay. I have to solve for dy dx. What on earth am I going to do? Can I multiply? Isn't this essentially right here? This is a fraction, true? So this is cosine x squared y over this, and then it's times this craziness right here. Can I multiply both sides by the reciprocal, meaning this is on the bottom and this is on the top? Does everyone see what I'm talking about? Yes? Yes, yes, yes. I just want to make sure. I don't want to do it, and then people are like, where'd that go? Meaning, essentially, I'm dividing by this and multiplying by this. So what we have is this still left. This is 2xy plus x squared dy dx is equal to, so this becomes 2 sine x squared y natural log of 2 over cosine x squared y. What is that? What could that be? Yeah, tangent. So we could simplify that even more if we wanted. But if you don't see it, is that okay? Totally, totally. All right, now this looks a little bit easier to start moving around. What do I do? What can I do? Subtract this, right? So then you've got x squared dy dx is equal to, I'm just going to leave all that. If you want to write it as tangent, that's totally fine. I'm just going to leave it. 2 sine x squared y natural log of 2, and this is all over cosine x squared y. And you said we're subtracting this. Do I have to get a common denominator? When I say, do I have to? Do you have to? No. No. What's my last step? Okay, so instead of dividing, can I say multiply by the reciprocal? Well, it's the same thing, right? But this whole thing, so this whole thing right here just gets multiplied by 1 over x squared. Okay, and because I ran out of room, this is my answer. Right? dy dx is equal to all that crazy stuff. Questions? All right. In a couple minutes, you'll go back to E, and we'll do that. But I want to talk about some of these properties. So back in, I don't remember, did we do this in Algebra 2? I doubt it, because did we do logs? I know you should have done logs last year in pre-calc. And there are 3 properties that are really important, and I'm pretty sure, like 99.9% sure, that these are actually in your concept cards. You're going to need these, okay? And you're going to need to know them to simplify problems, because sometimes it's going to make it easier. So the 3 main properties are that if you have the product that you are taking the log or the natural log of, you can break that apart into an addition problem. Okay? Bless you. if you are taking the natural log of a quotient, this becomes the natural log of anything in the top minus the bottom. Okay? And then if you have a term that has an exponent that you're taking the log or the natural log of, this exponent will become a coefficient. So you really do need to know these because it's going to help you and make your life a lot easier. Okay, and I will show you a very simple problem as to how to do that. Okay? All right.